Hey guys, Mr. Marone here, bringing you the first day of notes for G.C.9, which is all of the different angle relationships we have here in geometry. So we're going to start off with one that we've talked about in the past, but we're going to really define it today, and that is vertical angles. So just as a reminder, vertical angles are angles that share only a vertex. And more specifically, their sides are opposite rays, or they go off in opposite directions, and they create 180-degree angles when we have our opposite rays. So for instance, 1 and 3 would be a set of vertical angles. And we've said for a while that vertical angles are congruent, where they have equal measures. But we want to make sure that we prove that before we do anything else. In order to do that, let's take a look at our picture that they gave us here. And they want us to prove that DEA, this angle in here, is congruent to angle BEC. In order to do that, let's think of something else we already know, which are supplementary angles, two angles that create a 180-degree angle. Well, I've got supplementary angles here and here. I can say that angle DEA and angle AEB together equal 180 degrees. Okay, so that's one thing I automatically can say. The other thing I can say is that this angle here and this angle here, that angle AEB added to angle CEB also is 180 degrees. Now, since these both equal 180 degrees, I can set them equal to each other. I can say that angle DEA plus angle AEB is equal to angle AEB plus angle CEB. Now, if I notice on the left and the right side, I can subtract angle AEB on both sides, and those are going to cancel out, leaving me with angle DEA equal to angle CEB, which is exactly what we were looking for up at the beginning. So that's just a little quick proof to show you that all vertical angles will have equal measures, or the angles themselves will be congruent. Now, let's utilize that here and look at these three problems. So I'll do number 3 with you, and then 4 and 5 I'm going to pause the video and let you guys solve, and then you can come back and see the results. So to use vertical angles here, angle 2 is equal to 41 degrees. They're across from each other, so they are equal. They share this common vertex, and their sides create opposite rays. Now, to find angle 1, we either can set it supplementary with angle 2 or supplementary with angle 40 with a 41 degree angle. Either way, angle 1 plus the 41 degree angle equals 180 degrees. And when I subtract 41, I end up with angle 1 equaling 139 degrees. So I'm going to pause the video right now and allow you guys to try 4 and 5 on your own. All right, so now that we're back, you can see that in number 4, when I solved out, I got x equals 26. And in number 5, I had to find both x and angle CAB. So once I found x, I did remember to plug back in the angle CAB in order to find that it was 80 degrees. So that's about all there is with vertical angles. Now we're going to take a look at these angle pairs that involve what are called transversals. So a transversal is a line or segment that intersects two or more lines. Okay, so in this case, our transversal is right there. And it creates 4 different sets of angle pairs that we can look at here. Okay, the first one we're going to look at are called corresponding angles. So corresponding angles are angles in the same spot in their respective grouping. So for instance, we've got up here in blue, we've got this top 4 group, and then in green, we've got this bottom 4 group. So all of our corresponding angles are in the same spot, top left, top right, bottom right, in their corresponding group. Okay, so for instance, I've got angle 1 in the top left spot, and that's going to be the same thing as angle 5. top left spot in its bottom group. And we end up with 4 pairs. Angle 2 is congruent to angle 6, angle 3 is congruent to angle 7, and angle 4 is congruent to angle 8. And what we're going to do now is take a look at why we can say that corresponding angles are congruent. In order to do that, I'm going to do a bit of a transformation, which we've gotten comfortable with already. So if I've got this ray here, we'll call it ray AB. Okay, so there's my ray, and I'm going to have it translated. I'm going to slide it down along this ray here. So I'm going to slide it down. I'll change colors so we can see it. And my new ray will be A prime, B prime. Okay? So when we translate something down, or we slide it anywhere, we know that they stay parallel. Remember, we use the 2 bars for parallel. So sliding ray AB down along this transversal to A prime, B prime is going to keep the lines parallel to each other. And I've now just moved this angle up here down to this angle down here. So those two are going to be the same, and it's the same thing is true for all of my other sets that would exist right here. So just a simple transformation shows us that we can create these 4 sets of corresponding angles. Okay, so that allows us to have sets of corresponding congruent angles. Now, the second set are called alternate interior angles. So alternate interior angles, using this idea of alternate, that means that they alternate across our transversal. Okay, so they flip across this transversal. And when it says interior, it means it's between the 2 parallel lines. So there's 2 sets that we can look at. We have angle 3 and angle 6, and we have angles 4 and angle 5. And just like the corresponding angles that we have, we can say that these are congruent to each other. In order to show that these are, in fact, sets of congruent angles, let's take a look at some stuff that we already know. So we know that angle 2 is congruent to angle 6 because they are corresponding, what we just talked about. We also know that angles 2 and 3 are vertical angles, so those would be congruent. Okay? Since I have this shared quantity of angle 2, we can use what's called the transitive property to state that since 2 is equal to each of these things, they have to be equal to each other. So we've got angle 3 congruent to angle 6. And that shows us that alternate interior angles will also be congruent. Okay? Now, when we look at our third set, we have what are called alternate exterior angles. Alternate means they're still going to flip over our transversal, but exterior means they're going to be outside of our parallel lines. Okay? And we have 2 sets of these as well. We have angle 1 being congruent to angle 8, and we have angle 2 being congruent to angle 7. So if we want to do a quick proof of this, again, what we can do is use what we know in regards to our vertical angles, our corresponding angles. There's many, many ways that we can get to this setup. Okay, so we know that angles 3 and 6, like we just saw, are congruent by alternate interior angles. Okay? Well, angle 3 is congruent to angle 2 by vertical angles, and we know that angle 6 is congruent to angle 7 by vertical angles. Using substitution, taking this 3 and substituting in angle 2, taking this 6 and substituting in angle 7, we end up with angle 2 congruent to angle 7 by substitution. And our last set here are called same side interiors, or also called consecutive interior. Okay, once again, they are inside between the parallel lines, but since they are same side, they do not flip over the transversal. We have 2 sets of these. We have angles 3 and angle 5, and we have angle 4 and angle 6. And these have a bit of a unique relationship. These, in fact, create a set of supplementary angles. So together, they equal 180 degrees. Okay. And if we take a look at a quick proof of this, what we can do is use our knowledge of angles 3 and 6 being congruent, and they are alternate interior, which we learned earlier. And what I've got here with 5 and 6 are called a linear pair. I can say that angle 5 plus angle 6 equal 180 degrees because they are a linear pair. They create a straight line. Okay? And I can then substitute my angle 6's. I can take out the angle 6 here and replace it with what I know over here, that 6 and 3 are the same thing. And that allows me to say that angle 3 plus angle 5 equal 180 degrees using substitution. So we've performed a bunch of informal proofs here using our knowledge. We could have made it a much more two-column standardized format, but I feel like this is a much more efficient way to do it. And you've now created 4 sets of angle pairs that we can utilize to solve for missing values. We've got corresponding, we've got alternate interior, alternate exterior, all of which being congruent to each other in pairs, and we have these same side interior angles. So with all of that knowledge, I encourage you to try the problems in homework 1, found on pages 1 and 2 of your homework packet. See if you can come up with answers here. I'm sorry, just do page 1 for homework, just that front page, and see what you can come up with. If you have questions, please feel free to email me, and I will be able to answer anything that you might have a question on.